So, welcome to the presentation of the HopeMesh radio modules. I would like to show you how you attach these devices to a Linux-based operating system and how you actually manage to send data over the radio modules in the mesh network. So let me present here first the setup. As you can see here, I have a laptop, and on this side I have the first radio module, which you can see here. I hope the autofocus works. Yes, it works. So you see here the RAM, the SRAM, 32 kilobytes, externally connected to the ATmega162 processor. Here you see the latch, and here you see the actual CPU. The radio module is connected here using these level shifters, and you see the resistor array, and on this side is the Atmel AVR CPU connecting to the USB, and the USB cable is currently not connected. So let me reattach the camera to the laptop. Okay, and first of all, I would like to see if the operating system recognizes the attachment of a HopeMesh module. For this, I will trace the kernel log file here using the less command, and yeah, let's try to connect the module and on the USB port. So, and after a few seconds, essentially, you see a message in the kernel log that a new device was recognized, a USB ACM device available on the device descriptor TTY ACM 0. So essentially now everything is up and running. If you checked out the source files from GitHub, HopeMesh/src, there are some targets in the makefile which simplify the communication with the radio module. It's essentially sufficient that you write make com0 on the console. The only requirement is that you have a program installed called picocom, which is a low-level serial communication terminal. So let's see if it works, and it says terminal ready. So this make target actually only executes the picocom executable, enabling echo, because the current implementation does not echo back characters, with the speed of 38 kilobaud, and on the device which was recognized by by the kernel log. So let's see if the module responds back. If we press H as the abbreviation for help, the help command, it prints out the help message, and if you just press enter, it does the same. So it always prints help if it recognizes a command which is unknown to the module. Using C, you can look up the current configuration of the module. Essentially, the first configuration entry is the module address. In this case, it's 0x000B. So let's just call it B. So it's the radio module B. And the current routing table can be printed by issuing the command L. As you see, there are currently no known nodes on the network. So let's fire up the second module, which is placed on this table here. Let's see if I can mount the camera. Okay, so essentially I do the same thing. I connect the radio module to the USB port, and let's see if the kernel log recognizes the module. Yep, you see it recognizes the actual device, and we are essentially ready to go. Being in the HopeMesh distribution directory src, I issue the same command as on the other computer, make com0, and it says terminal ready. So again, let's press H for the help, and again it prints the help message. The configuration for this module is essentially the same as the other one, except that this radio module has the address 0x000A. And let's print the routing table. And as you can see, already the two modules recognized each other. So there's one entry in the routing table for the other radio module 0xb over the gateway 0xb. That means that they see each other directly. So this node is reachable over this gateway. So no hops in the sense of a mesh network are necessary. And this is the last sequence number of hello messages seen over the network. In this case it's 224. This variable calculates the amount of lost packets. Currently no packets were lost, and this is the total amount of received hello packets, hello Batman packets. In this case it's 48 packets. And the last time a packet was received in terms of seconds is printed here. This is the 47th second since this module is up and running. So let's print L again, and as you can see, the routing table is already updated. A newer sequence number is printed. Nice thing is we didn't lose any packets, and we already received 123 hello packets, and this is the current timestamp. So let's switch back to the other computer. Okay, so grab the focus. Okay, let's see what the routing table on this computer prints. And as you can see, the routing table prints 0xa, meaning that the node 0xa is visible to this node using this gateway, so it's a direct neighbor. And the same thing as on the other node. Here we actually lost 8 packets. I recognize that especially when you connect a module, this happens. These are mostly the first packets which are being lost, and afterwards actually everything goes fine. I just repeatedly press L to see if new packets arrive. The way the current implementation works is that hello messages are being sent every second, and so essentially when we print the routing table every second, we should see an update here. So let's see if we can actually send something. As you can see in the help, the syntax for sending a message is this one. Very simple. So we want to send a message to the other node. So we press S, 0xa, and a text. And I hope that the other computer received a message. I can look it up. Yes, I can see it here. And let's send a message back from the other node to this node. Let me just put this camera in here. Send 0xb hello back, and a little smiley. So as you can see, the other node received the message. Again, the routing table updates itself. So let's see what happens if we just switch off this radio module 0xa. As you can see, the terminal program picocom just recognized that the node is not available anymore. And when I go back to the other computer and print the routing table, you actually see it's empty. It's empty because we didn't receive any message since 10 seconds. The timeout for the purging timeout for the routing table is actually 10 seconds. So let's I will switch it on back again and print again the routing table, and you already see how new messages arrive. And I just switch it off again, and for 10 seconds the routing entries, as you can see, stay here as they are. No updates are being received, and after 10 seconds the routing table is empty. Well, I hope you had fun. I will switch off this radio module too. I encourage you to look up the GitHub repository and to check out the HopeMesh radio modules. Have fun!